Frames of reference. So far we've focused on how to communicate motion, but we haven't talked about who's doing the communicating of motion. So with this lesson, our essential question will be, how does a person's frame of reference affect the motion they observe and communicate? Our learning objectives will be able to define frame of reference. We'll be able to transform from one frame of reference into another. And we'll be able to simplify problems by changing the frame of reference. It's a lot simpler than it sounds, and it's kind of fun. Quick vocabulary preview. Frame of reference means the point of view that affects how a person measures and reports motion. Transformation is the act of changing from one frame of reference to another. Why do we care? We haven't discussed yet who actually observed these motions. Instead, we've assumed that it was us, and that we were standing still on Earth. Turns out that if we were moving, we would observe different motions than if we are standing still. And if we move differently, we would see motions differently again. If you move differently, you see other objects moving differently. It's a very important concept, and it completely changes anything that we've been talking about so far. Let's consider a velocity meter. The meter has a left sensor and a right sensor. When an object passes one sensor, it starts a timer. When the object passes the other sensor, timer stops. Knowing the distance between the sensors and the time to pass between the sensors, we can calculate the velocity of the object that passed the sensor. Velocity equals our displacement over time, or speed equals distance over time, right? That's how those little velocimeters work. They have two little light beams, and the distance between them is known, so it's the time that it takes to go through to pass through each sensor. So here's our velocity meter or velocimeter in action. Square grids are 1 meter wide. The sensors of the meter are 6 meters apart. The bullet travels 5 meters per second. There it goes. So when the meter sees the bullet, take 1.2 seconds to go the 6 meters. The distance is divided by the time to get 5 meters per second for the bullet. What if the sensor itself moves? Now it takes longer to go that 6 meter distance, right? Because the meter is traveling at the same speed and it's moving in the same direction. So the extra time makes the bullet take 1.5 seconds to move from sensor to sensor. So the meter thinks that 6 meters divided by 1.5 seconds, which is now only 4 meters per second. In the opposite direction, now it's going to take a shorter time to go the distance between the two sensors. So the decreased time makes the bullet take 1 second to move from sensor to sensor. So the meter thinks 6 meters per second divided by 1 second is, or 6 meters divided by 1 second is 6 meters per second. Does this mean that the velocity meter is wrong? No, the velocity meter does measure the correct velocity in its own frame of reference. A frame of reference is the point of view that an observer has that determines how the observer measures motion. This is what an observer standing still on the ground sees on the top. We can see the velocimeter is moving. But if we are moving at the same rate as the velocimeter, this is what the velocimeter is going to see. It's going to appear to be stationary, but the bullet is actually moving along with it. The bullet in the meter's frame of reference clearly moves slower, or appears to move slower, and the bullet in the meter's frame of reference clearly moves faster, or appears to move faster. So again, this one is standing still on the ground, and this is what the velocimeter is seeing. From now on, if we're talking about the frame of reference of someone standing still on the Earth, we will call this Earth's frame of reference, or Earth frame for short. If another object moves relative to Earth's surface, we're going to give that frame of reference a name based on the object. If it's a moving car, then people in the car are the car's frame of reference, or the car frame. If it's a moving train, then anyone on the train is in the train frame.